This is Algebra 2B, Trigonometry Lesson 6, period and phase shift. So, we're going to continue transforming our parent functions, sine and cosine. We're going to look at two new parameters today. For the first one, let's do sine bx or cosine bx. B. B stands for the number of cycles in 360 degrees. So far, if we've just been graphing sine x, cosine x, there's always been an invisible 1 there. We've been graphing one cycle in 360 degrees. But now we can stretch or shrink the length of our period, the length of our curve, using a number for b. Okay, so it's going to stretch or shrink, that's an R, stretch or shrink horizontally. And specifically to calculate the length of the period, we would do 360 divided by b. So if in like the ones we've already been doing, we've had sine x where b was the invisible 1, 360 over 1 means that the periods we've been graphing so far have all been 360 degrees. Phase shift. The parameter here, whether it's sine or cosine, is a number that gets added to or subtracted from the variable in the function. Phase shift is going to do a horizontal translation. And if you don't remember these words, when we talked about transformations of functions, that means we're going to slide the graph left and right. And so already sine and cosine are horizontal translations of each other. So basically, by adding or subtracting a number at C, we can turn each of our sine graphs into cosines and vice versa. Hopefully you remember this, but when we have a number inside and it gets added, it's actually backwards from what you would expect it to do. So I'm going to write this just with sine. I'm not going to write cosine again. But when you have x plus a number, the whole graph actually slides to the left. And it's backwards from what we would expect. When we have sine of x minus a number, the whole graph slides to the right. And I think I should have done this differently up top. Forgive me. I'm gonna change it. But these should have been minuses in here, not pluses. And there's a reason, because if we do minus a positive number, that's why it's sliding to the right. We're subtracting a positive number. But if we subtract a negative, subtracting a negative makes it go to the left, and minus negative looks like a plus. Okay? Let's give it a go. Describe each graph as a transformation of its parent function. So I also brought back some of the transformations we talked about in the previous lesson. Question A is just the new stuff, though. We have a 2 in front of the x, and we have a minus 90 degrees in the function. So a 2 in front of the x, b is 2, means that we are going to have 2 cycles in 360. And that also means that the period of our graph would be 360 over 2, so 180 degrees. So our sine function will repeat itself every 180 degrees. I also see the minus 90. That means C is 90. Now, I see a minus. That means C is a positive number. That means our graph slides right 90. Letter B, y equals 3 times the cosine of x over 2 plus 60. So I see three things. I see an A, I see a B, and I see a C on this one. So thinking back to A from the previous lesson, that is our amplitude. Our amplitude is 3, means that we have a vertical stretch and that the total overall height of our graph will be 6, right? Because amplitude is half the total height. So stretch. I'm going to just draw arrows instead of writing vertically. And that the total height is 6. B, not technically 2, technically a half. Because it's going to be invisible 1 over 2. B is a half. So that means we're going to have half of a cycle in 360. Half cycle in 360. And then we can calculate the period to see how long it takes us to finish one cycle. The period will be 360 over a half. Dividing by a half is the same as multiplying by 2. Okay, so it'll take 720 degrees to see one full cycle. And finally, C. C in this case is technically a negative 60, because if we see a plus sign, we're really doing minus a negative number. That is going to be a slide to the left, so we are sliding left 60. Last one, I have an A and a B and a C and a D. So A in this case is technically a negative 1. B in this case is a 4. C in this case is a negative 45. And our D is negative 3. What does it all do? Okay, so let's look at our amplitude. Our amplitude being a negative 1, it doesn't stretch it, but it actually reflects it. That means like our sign is going to go down first instead of up, reflects down. B being 4 means we're going to see 4 cycles in 360. And to calculate the period then, if we do 360 over 4, it means one period would be 90 degrees. With C looking like plus 45, meaning it's actually a negative 45, we are sliding left. And with D being a negative, we are actually sliding down 3 units. Cool. Letter B, write an equation for each graph. 1, sine or cosine. If I look at the center, I see that S shape. I know he is a sine. I like to do D. We're looking for the center. The center looks like it's right at 0, which means I'm going to have a plus 0 at the back. I can totally ignore D. Amplitude is half the overall height, so it looks like we're going up to 3 and down to negative 3. 3 to 3 means a height of 6, so my amplitude is 3. It is going up at the beginning, so that's a positive 3. Next, we're looking at our period. This is what we talked about today. So this is 360 degrees. I count 1 period, 2 periods. So B is 2. I don't have a vertical shift on this one because he is right at the center. If my intersection point had slid left or right, that's when I would have looked for a phase shift. And I already said D was 0, so that looks done. Let's graph him to check him. It looks pretty. Letter B, sine or cosine. I see a U in the middle. That tells me it is actually a negative cosine. I'm going to leave space for a number there. Let's do period next. Starting here, that's 1, 2, 3. 3 cycles in 360. That's 1, that's 3. Total height is 2, which means half the total height is 1. So I can fill in the negative 1. I can leave them off too. I don't really need the negative invisible 1. And phase shift, I kept him right at the center, so my phase shift is 0. Last is vertical shift, so we're sliding up to the center. Center of our graph looks like he's right here at 0, 1, 2. Give him a check. Negative cosine 3x plus 2. He looks pretty. I got 2 more. Now I got some phase shift examples. So with phase shift, because you can always keep sliding to turn a sine into a cosine, you can pick any one you want. I'm going to pick cosine for both of these. And the reason is my top of my cosine is pretty easy to identify. Okay, so I'm going to choose cosine. And amplitude goes down to 1, goes up to 3. That's a total distance of 2, but half that distance is 1. So you can put the invisible 1 in front, or you can leave them off. The center line right here is at 0, 1, 2. So I'm going to put a plus 2 way at the back. Starting here and then ending here, that is exactly 1 cycle. So again, you can put in that invisible 1 for 1 cycle or leave them off. So now I have to figure out how far he slid over. I know that I scaled this by 90s, and that looks pretty close to the middle to me, so I'm going to say 45. Now it did go to the right 45, so I need to do minus a positive 45. I wrote it with the invisible 1s, but I'm going to leave them off when I type it, so we can do invisible 1 cosine, invisible 1x, minus 45, and at the back we have a plus 2. I like it. One more. Again, you can choose sine or cosine. If you're looking at sine, then you're looking at the middle of the S. But I think it's a lot easier to look at cosine, the top of the C shape. Okay? So cosine. That goes down to 1, 2, 3, 4. Negative 4 at the bottom. And positive 2 at the top. Total height is 6. Half that height is 3. My center does look like it is at negative 1, so I'm going to have a minus 1 at the back. I only count 1 cycle here, so 1x. And he looks like he slid a little bit to the left, so we're going to have a plus in there. I'm guessing 30, because it's like a third of the way to 90. Not quite half. Yeah, let's give that one a try. Three cosine x plus 30 minus 1. It's beautiful. And so just to reiterate, I chose cosine and made it work. I could have chose sine instead. 3 sine. That's not what I wanted. Delete. Delete. That's what I wanted. 3 sine, 1 cycle, but I could have gone to this point instead. So let's say 120, because it would have been 90 plus 30 more, 120, plus 120 minus 1. So just to show you guys, that's the first graph. And then it's still graphing, but you're not seeing anything because the two graphs are overlapping. And I can go to the table to show the table of values for my sine graph and my cosine graph. They are identical. And we could have said, hey, let's slide to this point and then use a negative cosine. Or, hey, let's slide to this point and use a negative sine. So there's lots of different possibilities when you work in phase shift that you can use a whole bunch of different functions and still come out with the same graph. Okay? I know that's a lot, but that is our last bit of notes for this whole chapter. We have a project after this. That'll be super exciting. But good luck with these exercises, and please let me know if you have any questions.